Hi everyone, today we're going to learn about how to create hydraulic fracture in Model Designer via LGR. And now I have opened my T-Navigator newest version, and I have created new MD file here. Now we move on to geometry objects. We have many fractures feature here. Today we're going to use fracture path, fracture template, fracture stage, and fracture arithmetic. We're going to use these four to create a fracture in a model. First, I'm going to import the model. Now, we have two wells here. And first, I'm going to create a fracture path for each well. And we are going to create a single stage fracture for one well and multi-stage fracture for the other well. First, we are going to create a fracture path here. Right mouse button click, we create new one, fracture path 1, and fracture path, right mouse click button again, fracture path settings. Here we're going to input the fracture path minus 150. Okay, we already defined the properties for fracture path. For example, here the fracture path defines a planar fracture parallel to the y-axis with a half length of 150 meters. And then we can close it. Then we're going to create another fracture path for the other well. First, we created a polygon here. We click on this button right here, edit polygons, and then we choose the well. I choose the well 2. Then we draw a V shape first, 1, 2, and double click here. Then the polygon name is line 1. Okay, and we create another one here, line 2. Okay, now we have two polygons here, line 1 and line 2, as seen in the screen. And then we're going to create the fracture path via polygon. We create a new one called fracture path line 1 and fracture path line 2. Can duplicate it and name it line 2. Okay, and then we're going to right mouse button click here and show the settings. Now we show the calculation, and then we can choose it, create fracture path via polygon. We choose the line 1 and the anchor point index is 2. Apply, and we can choose this one. Choose the polygon for line 2 and remove. The anchor point index is 1, and then apply. We have new fracture path here in the well 2. And then we're going to create the fracture plane. plane, right mouse button click, fracture plane settings, choose the fracture path, line 1 and line 2, close, and we have a new fracture plane for this fracture structure. And then we're going to create a fracture template for wall 2 here. Create new one. I'm going to name it 2. We have many settings here. We're going to input to the table. Fracture plane 1. The up is 7, 5, 1. Yeah, you can see the input is depicted in the picture on the right. And then 1000. We have SRV expansion. It's to the left and to the right 50 meters. Okay, we can close it now. Close. And we're going to create fracture arithmetic. Here we have all of the fracture arithmetic, and we're going to create it one by one. First, for permeability X and all DP all zones, only in fracture zones, constant, value at the origin 1000, and this one 1000. We can copy it here. This one is for near fracture zone. Okay, and then we're going to copy this one, and we can choose from Y, from G. Okay, can close it. Oh no, we can choose either this one is constant, linear radial, linear vertical, or exponential radial and vertical. For fracture zone, we choose the constant one. For near fracture zone, we can choose linear radial. Okay, we can close it. Now we're going to create fracture stage. Here, we create a new one. Fracture stage 1. We choose the fracture template 2. The MD is like this, 2250. We choose the well 2. And it's right, single stage fracture. We close it. And then for the well 1, we're going to create the fracture template here. Okay. We open the template settings. Fracture path name, this one. And then we're going to have the same parameters. Okay, it's 50. Okay, we can close it. Now we're going to create a new fracture stage create. Okay, and then show the fracture state settings. We choose the multi-stage fracture for well 1. Then we can choose the fracture template 1. Start and date in 2100. This one is 2300. Number of stage is 3. And then we have created 3 stages of fracture here. We can close it, and we're going to show it in 3D. We can open the 3D tab. Here, how to show it. First, we have to make sure we check on the right grid here. And then, for example, we have shown the properties here. And then we have to uncheck the show grid. And we can check on the fracture stage to show our fracture. Okay. Now we go to the wells data. We have to edit the strategies here to input the fracture on the schedule. We click on this timestamp and we add a new rule here. Enable fracture. And then we're going to choose this fracture. And we choose the fracture arithmetic. The fracture arithmetic can be a global fracture arithmetic that used for all of the fractures that we created. Now we are going to add new rules again. Here, click add new rules. Then we can choose fracture stage perforation. Choose for well 1 and well 2. The delta is going to be 15. And the status open for this date. Then add new rules again here for well production limits. Focus and well 1 and well 2. We use control mode bottom hole pressure and keep it default 50 barsa here. And then now we can initialize our project. Yes. Okay. Now we can open it here and then we run it. We show the grid. We can choose the calculated pressure. We can see the pressure in real time here. Now I'm going to explain what is the algorithm of parameter specification that we have created before. We have created fracture path, fracture templates, fracture arithmetic, and fracture stage. Fracture path is flexible. It can have an arbitrary 3D geometry. The same fracture path can be used for different fracture stages. And then fracture path is the polygon that defines the fracture geometry in 3D. If the points of fracture path have different g coordinates, the fracture will propagate both vertically and laterally. And the next one, fracture template. Here, for example, um, these are the required parameters for fracture templates, and this is the optional one. And by default, some parameters are ignored due to unstructured grade refinement. For example, LGR size, and then refinement type, maximum layer, number up and number down, and then the set of required parameters including the plane name or path name, and then up is the fracture height measured upward of the anchor point, and then down is the fracture height measured downward from the anchor point. Fracture width is the width of fracture zone on the grid, and we can show it here. Okay, and then permeability in fracture zone is the permeability in the specified zone. For SRV expansion to the left is the width of the fracture stimulated zone to the left of the anchor point here. And this one to the right. You can close it. And then fracture template. Um, we have additional parameters too. We now move on to the result of this project. We can move to graphs tab. We can show the result here. We can use the predefined templates. We can open the Wells LGR file here. For example, we want to see the transmissibility factor. I'm going to add a new graph template here. Transmissibility factor. And choose wall one. And wall two. Okay. We can choose also the LGR level that we want to see. And that's all for today. Thank you for watching.